first finish. Flatness means much more than that. That means it's on over a length. So it has a much length, or it's called the waviness. So how the surface it is based on manufacturing basically. So if there is a tool chatter or vibration, this waviness will increase. So you won't get so controlling all those will get a flat part. And again it's as it is based on the machine. The flatness, higher the flatness, higher you have to go for the costlier machines or processes like that. Then the second one is straightness. Straightness means how straight your part is. I would say this one, so how straight it is, deviation from the a straight line, or kind of. Then circularity means it's controlling, the feature is controlled is the circle. So how whether it can change from an oval shape to so it as the rule number 1 says that you can deviate between the outer and the inner ones, right? The maximum material condition and the least material condition. So it can go from oval to a perfectly circular shape. That is called circularity. So if you add circularity and straightness, you'll get cylindricity. Straightness comes from length, right? And circularity on over a particular section. So cylindricity controls the entire thing, like entire feature, where it controls the circularity as well as the straightness. So instead of calling circularity and straightness separately, you can just call cylindricity with one way or one go. Then what is profile? Profile means shape. So how this shape is, whether it is flat or especially something like this, you need to control the entire thing. You don't need to control each and every one, right? So you use profile. So what you do is that you define a nominal what do you call it, shape, and with respect to you can the profile can vary from a higher limit to a lower limit, or maximum material to minimum material condition. That's how the profile is called out. So it can be line profile. Line profile means it applies only to one section. It's the line profile, and surface profile means everything over it, the complete length. Just like circularity and cylindricity, you have line profile and surface profile. So everywhere this variation has to be taken into. Then what you have is this perpendicularity. Perpendicularity means how one thing is perpendicular to another surface, just like this. And angularity. Perpendicularity is a special case of angularity where the angle is 90 degrees. So for all other angles you have this angularity call out in there. And parallelism, again, if the angles if it is infinity, then it's parallel, right? So if the angle between two surfaces are infinity, you get parallelism. So that's what parallelism, orientation, basically. How each two surfaces are basically like that. Then run out. I'll tell you in a video. Just think that I think. You might have seen the dial indicator where you have a dial, a needle, and there's a plunger or a probe that goes. I mean, if you put the probe in on this surface, based on the finish or the shape, it will go up and down. So this needle will what it measures is the run out. So what I will do is that I'll put this dial indicator here and then rotate the part. So for one complete rotation, you will get the one. Sorry. one or the circular runout, which is the one arrow there. If it is two arrows, that means total runout. That means it goes from one over the length. So I have to measure not only put this plunger like this with measurement. Also goes. I have to take different areas. So over here I'll get one measurement, then another measurement, full rotation on all places. Then that is called the total runout. Let me show you the video. So it doesn't have any voice, so don't bother about that. So just to show that, so this is how the runout is measured. You can see that the needle will go up and down based on the surface, how the so it's runout is used. So I'll show you again. It's a small video. So here it is a chuck. In inspection or the quality, what you do is that I'll keep it in a V block. V block means it's in the shape of a V. I keep it in a V block and rotate it. That's how I do it for inspection. So runout is just like you can call runout or cylindricity. So depending on your needs, you can go with runout or cylindricity call out. So usually runout is easier because you can use that. So just like I said, it's an analog one. You nowadays you can get digital ones, where you can read out everything from a digital readout. A small LCD screen will be there. Then you have concentricity. So when you have two parallel circles like this, or if you can see here, then you call it by concentricity. Two different, one big circle and a smaller circle. Then you can call either ways. With respect to the big one, you can call the smaller one, and that depends on your. So if your important feature is the bigger one, then you call make that as a datum and call with respect to that the smaller ones or all the others. The position I said, it's based on where the location. Position means location. That is the crossbar circle with a crossbar on it. Then symmetricity. Symmetricity means basically how symmetric it is. So you call it with respect to a central line. Most parts are symmetric, right? So you can use that, but it is the least used. I have seen symmetricity very rarely. Use it, but when you have a symmetric feature, it is always better to call symmetricity. No problem in that. And coming to profile, I'll just add something. For example, many plastic shapes and all, it's difficult, right? Just like something goes on the even the hood of the hood of your car, or the bonnet of your car, it has a particular shape, right? So those things and all you can call easily with respect to your profile. So you can nowadays you can use CMM, or you can use different kind of other methods using light and all, or even laser. You can measure the variation in heights, and basically in those drawings you
Excuse me, sir.
Yeah.
What is it? CMF, sir? I didn't get it.
A CMM is the coordinate measuring machine.
CMM. Okay.
Yeah.
Coordinate measuring machine. Okay.
Yeah. I'll show you here. I think one I have here. This one basically. So basically you have a probe here, coming. It may be like inclined, or different probes are there, and basically it can go in X direction, which is on the bridge, and the bridge itself will move back and forth, which is the Y direction, and the C direction or the Z direction is the up and down motion. So and your one of your datum will be your the granite base plate, or the surface here, which is highly precision grounded, or it's finely grounded. It's most of the costlier CMM use the granite plate. And then you can have other datum surfaces as well, two perpendicular ones, as you have seen. So that those are you can use as the reference. But in CMM, you just need to if it is a simple part and all, you just need to keep it like this, and by virtually it knows where it's other datums. So only A is you constrain it, and just keep, if you can keep it just like that flat one, that is fine. You can put a like a kind of it's like a bubblegum kind of thing is there. It's a kind of a wax actually, so you can stick in there so it won't move. It's this one, and it will comes off easily. It's like kind of a bluish kind of this one. So that's how we fix it. Or you can use clamps also. Anyway, you can use. So, and then this probe will touch each portions. Even if it is circle or something, it goes in and get so many readings, and then it it already knows where it is. All the with respect to that is done with initially you have to do the what do you call it, kind of a I'm not getting the proper word. You have to use a basically they use a ball, either ceramic or highly machined, or it's mostly it's a ceramic ball that it used to calibrate. Okay, that's exactly. So initially it calibrates itself with respect to something, a ball or something, so that it knows spatially where each thing is located. Then that after that calibration is done, then you put your part in there, and then it measures everywhere. So that's what it is. That's there's the same video. The YouTube link is also there. And these are some of those. I haven't put everything in here because it's a lot, and it will confuse you. For a starter or preliminary, getting it and introduced, this is enough. Once you start using this symbols and all, then you get to the intermediate level. That gets only through practice. Right. So if you are welcome to practice on your projects or anything, and I'm happy to help you out. So I've been seeing many drawings and everything, and mostly on the supervision or managerial side. So I have reviewed so many drawings and all. So even I have reviewed it for some authorities like FA and all. So I know things are. So and only after 3 to 5 years you go to an intermediate level, and after that only you get to master. Master means the higher level of that kind of authority kind of thing. Right. So we talked about the rule number 1, where we saw the upper limit and the lower limit, which is controlled by maximum material condition. For external features, it is the outside one. For the internal feature, like a hole, it's the inside one. Inside, because when you have the smaller hole, you will have maximum material in there, or the weight will be more. Right. So that's how for inside dimensions, it is the inner one, and the outside dimension, it's the outer one for max material condition. the maximum material condition, and least material condition is the other way. When you, the for outer dimensions it's the inside one, and for the inner dimensions it's the outside. When you have the maximum diameter allowed, then you have the least weight or the least material. That's why it's called least material condition. Then you have free state, something like a gasket or something. What it says is that you have to measure it in a free state, without constraining. Without constraining, you have to measure it. That's what this F's with a circle symbol. Then the tangent symbol. And, suppose you don't have a perfectly flat surface. So this is very rare case situation. The tangent plane is where you specify a tangent plane which is the peaks. It takes the peaks of this this, because each if you go minute case, it will have a peak and a low